Right, heavy versus light objects in freefall. Will a heavy object fall quicker than a lighter one? No. Well, the accelerating force of an object is equal to the mass times the acceleration. So if something weighed 1 kilogram and its acceleration was 5 meters per second, it would just be the force would just be 5 newtons. So force equals mass times acceleration is usually wrote as F equals ma. The m and the a beside each other just means you multiply them. Sometimes you put a period in between them just to show this, but I tend not to. As is under free fall, the accelerating force is gravity. In equations, gravity is usually shown by simply writing g. Gravity in physics is usually taken to be 9.8 meters per second, but to keep it simple, we will use 10. Now, note in algebra, meters per second with a wee slash in between can be wrote as ms to the -1. It usually is in A level in physics and maths. They usually prefer the ms to the -1, so just a quick tip. Not really that important. Let's take a 5 kilogram ball and drop it using F equals ma, and assuming gravity is 10 meters per second, we get F equals 5 times 10, or 50. As force is measured in newtons, this is 50 n, or 50 newtons. Now let's take a lighter ball, say 2 kilograms. Using the same formula, we get F equals 2 times 10, or F equals 20 newtons. So there's less force acting on it as compared to the force of the 5 kilogram ball, so it should drop slower, right? No, if we rearrange F equals ma, we get F divided by m equals a. This means the larger the mass is, if the force is large and the mass is large, then it will give a small answer because you're dividing it by the mass. So the larger the mass, the more spread out the force is. So for the 5 kilogram ball, we get 50 divided by 5 equals 10 meters per second, which is gravity, so its acceleration is what we started with. For the 2 kilogram ball, we get 20 divided by 2 equals 10. As you see, both the 5 kilogram and the 2 kilogram ball have the same accelerating force, so their acceleration is equal. If acceleration is equal, they will fall at the same velocity. I know them as a Suvat equation, I'm not sure what you know them as, but basically velocity equals your initial velocity plus your acceleration times your time. Assuming that we start from rest, well, we start at 0, so our initial velocity is 0, so we can just exclude u. Therefore v equals at, or your velocity equals your acceleration times your time, how long you're traveling for. But how can the object with more force acting on it have the same acceleration and therefore velocity as one with a smaller force? A simple answer is inertia. The large object is less willing to change its velocity. Pushing a door open easy enough, pushing a car not so easy. Thanks.